Welcome to the Math Record. Today we'll be learning about division in Precalculus. This will be part 3 of chapter 2 in our Precalculus class. In our previous video, we talked about properties of Precalculus. Now we're talking about Precalculus processes and theorems. In this video, we'll tackle long and synthetic division and the remainder theorem. Okay, let's begin with long division. This process is basically a method to find the result of a polynomial f of x when it's divided by a constant. So you might be asking, how does that work? Remember in elementary school you had something like 7 divided by 2 equals like 3 and 1/2, where the 1 is the remainder and the 3 is the quotient. Well, basically polynomials do that, but with linear equations. So let me give you an example. You had something like f of x is equal to x to the power 3 plus 4x squared plus 7x plus 5, and you want to divide that, this is the divide sign, by x minus 1. Long division would be like similar to how you do with numbers. So now the first thing we want to do is that we want to get to the x cubed term. So what multiplies x minus 1 would get to x cubed. That would be x squared. You put x squared, so that would be x cubed minus x squared. See how? So that's x cubed, and that's x minus x squared. So you minus those. So you the x cubed cancel out, and you get 5x squared left over. Now you want to cancel out the 5x squared. So what you do is that you put 5x. So that'll be, drop down the 7 here, and you get 5x squared minus 5x. Subtract. And that leaves you 12x plus 5. Now you plug in, now you want to cancel out that 12. So you put 12 in now. So that's 12x minus 12. Subtract. That subtracts, that gets 17. So we get this number, remainder 17. Because there's nothing we could do about it. Because this is a constant term, and this is a linear term. Sorry, I'll rewrite that so it's a little bit better. Remainder 17. So that's how you do long division. In this process, you just like do the you just multiply. You look for the term. You multiply by that, like a term by less than that, and you kind of like subtract away until you get like a term that you can't like divide further. So that is for long division. Now let's do synthetic division. Synthetic division is a faster method. So what you would do is that you will list out the coefficients of the polynomial, and you would just do it from there. So we want to divide by x minus 1, and the thing that we want to divide from is x cubed plus 4x squared plus 7x plus 5. Right? So the coefficients are 1, 4, 7, and 5 from order. So 1, this one, 4, and then 7 and 5. And then we're going to make that box again. And now we're going to divide by 1. Because 1 is right here. Because 1 minus 1 is 0. That's what you want to get. So if this is x minus 3, you put 3. If this is x plus 2, that is negative 2. You get the point? So what you do is that you draw another line down here. Whatever this term is, you drop it down to the bottom, and you multiply these two terms together, so that gets 1. Just trust me, you just need to memorize how the process goes. You're gonna get it as I show you. So you multiply this, this and this together to get 1, and then you're gonna add these together. That makes 5. And then this multiplies by 1, so that gets 5. And you add these together, that's 12. And you multiply 12 by 1, which to get 12. And 17 plus 12 is 17. So you just keep doing that. You just drop down the first term, and then you multiply that term by that term, and you add those, and then you drop down the new term, and then you keep multiplying, and you keep doing that until you get like the last term is going to be the remainder. And this these three terms are going to be the coefficient of the new terms. So what these tell me is that it will be x squared, because x squared times this equals x cubed, right? So it has to be an x squared, but the coefficient is 1. So the next one has to be 5x, and then plus 12, and then remainder 17, which is exactly the same as we got for the long division. So this method is faster. The only reason that you should use this method is that, like, if it's just with linear terms. Let's say you don't divide by x minus 1 and you divide by x squared plus 1. In any case that's not linear, it's something like this, then like even if it's like x cubed plus 4 or something, like x fourth plus like 5 or something, if it's not linear, then you cannot use synthetic division. You have to use long division. So if you have like something like this, right, you gotta have to do long division. So what you'll do is that it'll be like this: x cubed plus 4x squared plus 7x plus 5. It's the same process. So what multiplies the x squared plus 1 to get the x cubed? You multiply by x. So that's x cubed plus x. Subtract them together, you get 3x squared plus 7x. Drop that 7x down. And you want to multiply this by 3. You get 3x squared plus 3. Subtract them together. You get 7x minus, this is minus 3. You gotta add that 5 there, so that's a plus 2. Because that's the negative 3 right here. Negative 3 has to go somewhere because these terms are not the same. So so you have x plus 3, remainder 7x plus 2, all over x squared plus 1 because of this. So that is synthetic division and long division. So if you see a linear, just so a summary, if you see a linear, just use synthetic division. It's the easier method and faster, because you don't have to write as much. If you want to use long division, that's just to check. So if and long division, you use it for like anything else that's not linear. Now we're gonna learn the remainder theorem. The remainder theorem just tells us that if f of x, the polynomial, is divided by like x minus a, then the remainder of that polynomial is equal to f of a. That's what it's telling us. So like in the case that we talked about, where f of x is x cubed plus 4x squared plus 7x plus 5, and our thing is x minus 1, and we want to find the what's the remainder, then you just plug in 1 into this. So you get 1 plus 4 plus 7 plus 5. So that's 5, 12, and 17, which is correct because we did this in long division and synthetic division in the examples before. So there's also a general way to write this. So basically, the for remainders, how you write for long division, synthetic division, using these equations, you have f of x is divided by x minus a will equal the new equation, which is g of x, plus f of a, because that's the remainder theorem, tells us over x minus a. That would be the remainder over the constant. So you multiply these together. This multiplies by the g of x. So this would be equivalent. Let's just say we multiply x minus a from both sides. And that means you get g of x times x minus a plus f of a. So this thing will be the same thing as this. And that's the general method. So this will be considered the quotient. This is the quotient. Remember how, like, in the case with like regular algebra sum over 2, where you had 3 and 1/2? 3 would be the quotient, 1 would be the remainder, and 2 would be like that factor. So that's the same thing. So this would be our quotient, this would be our factor, but you have to multiply it, and then this one is our remainder. See, so that adds up to our overall polynomial. So basically, just use just use synthetic division or long division to get g of x and the remainder. And if you just want the remainder, just use the remainder theorem. Well, that's all for today. Thanks for watching, and I'll see you at the next math record video.